Hello, today we're going to talk about nuclear fusion, what it is, the differences between fusion and fission, and the benefits of nuclear fusion. We're also going to talk about the problems with nuclear fusion and a solution for it, starting with what nuclear fusion is.
Nuclear fusion is when energy is produced by smashing lighter atoms together. For this reaction to occur, two nuclei have to come together so that the nuclear forces glue the two together. These reactions take place over high temperatures and short distances to overcome the repelling electrostatic forces.
You have hydrogen, the lightest element. You can fuse hydrogen atoms together and get heavier elements. And that takes heat, so thermonuclear fusion.
The difference between fusion and fission is that fusion is the merging of two smaller atoms resulting in a larger atom and the release of an abundance of energy. The waste product of fusion is helium. Fission, on the other hand, it's the splitting of a larger atom into two smaller ones resulting into the release of energy. The waste product of fission is a radioactive material.
Why is fusion beneficial? Nuclear fusion can be beneficial because it is efficient and eco-friendly. The resources of deuterium is virtually unlimited because of the amount of natural abundance. And it is safer to work with and better for the environment. Deuterium is a stable isotope, so explosions are impossible, and the only waste that is produced is helium.
Fusion naturally takes place in the center of a star because its mass is so great that the conditions required for fusion are met by the sheer pressure and friction.
Stars undergo fusion.
Right.
And if you have enough mass, it'll go hydrogen to helium. And it'll do that in its core, and then and a star is in the business of making energy.
Right.
That's all they know how to do. That's all they do.
Unfortunately, it is not feasible to recreate such mass on Earth, so we have to come up with our own ways to recreate the conditions of a star's core. As of now, all of our methods to recreate the conditions of a star's core require more energy to produce than what we get back from the reaction itself. To summarize, our current problem is that we are putting in more energy into the reaction than we are receiving out of it.
The current approach to nuclear fusion is using a donut-shaped electromagnetic plasma reactor. We conclude that the best solution to fixing this problem is to research and engineer a nuclear reactor that gives more energy than it takes.
References.